Hi everyone! Today we're going to be talking about the basics of radicals. So, first of all, what are radicals? So, radicals or roots are basically the opposite of squaring a number or putting a number to an exponent or raising a number to a power. So, for example, when we have the square root of 9, this is basically asking us what number squared equals 9. And this is 3 because 3 squared equals 9. And so, for example, let's say we have the square root of 4. So this is the same thing. What number squared equals 4? And this is 2 because 2 squared equals 4. And then this is a square root, which is when you square a number. But there's also a cube root where there's a small number here, and it's called the index number, I think. And so let's say we have the cube root of 8. And this is asking us what number cubed equals 8. And this is 2 because 2 cubed equals 8. And it goes further. There's a fourth root and a fifth root and sixth root and on and on. And so you might be like, where's the second root? Well, this is the second root right here. And so basically, the square root, which is this, is the same thing as writing just the square root without a number here because it's like easier to write it that way, I guess. So yeah, I hope you understand what a radical is. So here's some practice problems. I'm sure you maybe know how to do this already, but we're going to review it. So the square root of 81, you're going to ask yourself what number squared equals 81, and that's 9 because 9 squared equals 81. Then the next question says the square root of negative 81, and this actually has no real solutions. And this is because a number squared can never equal a negative number. So for example, even if we had negative 9 squared, this would equal positive 81. And this is negative 81. So there are no real solutions to this radical. So the next question, you're going to ask yourself what number to the power of 3 equals 64? And this is 4, because 4 to the power of 3 equals 64. In this case, there's a negative inside the square root, so you might think, oh, there's no real solutions. But actually there is, because let's say you take negative 4 to the power of 3, then you get negative 4 times negative 4 times negative 4. You have 3 negative values, so when you have 3, the answer is also going to be negative, because these negative signs might cancel out, but then you're left with one last negative sign. So 4 times 4 times 4 is 64. So this is going to be negative 4. Okay. So here's some harder problems, and they're basically the same thing as what we did before, except you're going to have to do, there's going to be more like numbers and variables in the radical or in the root. Okay, so first what we're going to do is we're going to choose the numbers inside here that can be squared. So for example, 32 is not a square number, but we know that 32, some of the factors of 32 are 16 times 2. So if we have 4 squared times 2, we know that we'll be able to take the 4 out of the radical because 4 squared is, or 16 is a square number. And here we have x squared, so we have x squared. And we know that that can also be removed out of the radical because it's to the power of 2. And then we have y to the power of 5, and that can be split up as y to the power of 4 times y. And then when we simplify this, first we're going to think of what numbers can come out of the radical. So first we have 4 squared, so we know that 4 will come out of the radical, and x will, so I'm going to underline this. So we have 4, and then we have x squared, and we have y to the power of 4. So then we have x, and I wrote x and not x squared because when it's out of the radical, it's what number squared equals x squared. That's just x. And then we have y to the power of 2. Then we're left with all the numbers that are still left inside this radical, which are 2 and then y. So the answer is 4x y squared times the square root of 2y. And this is the simplest form because we can't simplify root 2y any further. So the next question, when we have the cube root and we have it both on the numerator and the denominator, so we can also write this as 3, the cube root of x to the power of 6 over 64 y to the power of 3. And then we're going to do something similar to what we did here. We are going to think of what number to the power of 3 equals the numbers inside of the root. So here we have x to the power of 2 to the power of 3. which equals x to the power of 6. And then here we have 4 to the power of 3 times y to the power of 3. So what we're trying to do is we're making everything inside here to the power of 3. And we don't have any left out numbers, so this is good. So we have our answer is x squared over 4y. Okay, so that's our answer. So the next thing I'm going to cover is rationalizing the denominator. And so sometimes when a problem asks you to simplify a problem and then you do all the math and then you're left with a square root or any root on the denominator, that's not the simplest form. And you have to rationalize the denominator to get rid of the root on the denominator. So what we do is we'll multiply this by a number, and in this case, so for the first question, we're going to multiply this by root 2 over root 2, which is basically 1. But the reason why we multiply it by this is because the denominator, when we multiply root 2 times root 2, we get 2. So then we get rid of the radical, and that simplifies the fraction. So then root 3 times root 2 is just root 6. So this is our answer, and this is a simplified form of the equation. But sometimes here, like if for this problem, you have a radical on the denominator, but you can't just multiply root 3. So in this case, we're going to multiply this by root 3 minus 1, and we're going to do that to both the numerator and the denominator, because that equals 1. And so we do this because when we multiply the denominator, we have root 3 times root 3, which is just 3. Then we have minus root 3. Then we have plus root 3. And then we have minus 1. And if we multiply the numerator, we get 2 times root 3 minus 1. But when we simplify this, we can do root 3 plus root 3, which is just 0. So we have 3 minus 1, which is 2. And so now we have gotten rid of the radical in the denominator. So then we have 2 times root 3 minus 1 in the numerator. And in this case, we can simplify this even further by dividing 2, and then we just get root 3 minus 1. So that would be our answer. Okay, so thank you for watching, and remember to subscribe to my channel if you like this video, and also like this video, or give it a thumbs up. And also, I will be making another video on radicals next after this. Okay, so thank you for watching.